Good morning, children. Let us start the second lecture of the chapter Unit and Measurement. In today's lecture, I am going to cover the topic Measurement of Large Distances, Accuracy and Precision in Measurement, Errors, Absolute, Relative, and Percentage, and Combination of Errors. So let us discuss one by one. Measurement of large distance. Now, in the previous lecture, you have studied that how we can measure the distances directly. That is using the meter scale, vernier calipers, and the screw gauge. Now, if we want to measure the large distance, like the distance of a planet from the Earth, then we have to use some indirect method. So let us discuss this. Now, parallax method. Now, what is the meaning of the parallax? Parallax is Now, what is parallax? Parallax is the apparent shift in the position of an object with respect to another when we shift our eyes sidewise. What does it mean? Now, listen carefully. Now, just keep your finger in front of your eye and look at the finger with one eye closed with respect to the wall. Then close your another eye and look at the finger. Now look your finger one by one by closing your eyes. What you observe? You will see the difference in the position of the finger when you look at the finger by closing your right eye and when you look your finger by closing your left eye. In each case, the position of the finger is changed. So this is what is the apparent shift in the position of an object with respect to another when we shift our eyes sidewise. The closer object always appear to move in the direction opposite to that of our eye. Means when you are closing your left eye, you will see that your finger is moving to right side, and when you are closing your right eye, the finger is shifting little bit towards left side. So this apparent shift is known as the parallax. Now this method is used to find the distance of a planet. So let us discuss to measure the distance d of a very far away of planet S by the parallax method. We observe it from two different positions. So how two different positions? We will place the two observatories on the earth at two different positions, and with the help of that observatory we'll look to the planet. So these A and B are the two observatories on the earth separated by a distance AB is equal to B. At the same time as shown in the figure, we measure the angle between the two directions along which the planet is viewed at these 2 points. Just this is the planet, and A and B are the two observatories placed on the earth. These observatories are placed at a distance B on the earth. Now when the planet is observed at the point from the observatory A, and again it is looked by the observatory placed at B, then the angle between these two is taken to be theta. This angle is to be calculated. Then we approximately take AB as an arc of length B of a circle with distance at. Now suppose this is a circle. Now this position A and B is an arc. Now if the circle is of very large radius, then you will find that this arc, for a smaller circle, the arc is more curved in comparison to a larger circle. As the radius of the circle increases, then the arc, instead of being more curved, it looks like a straight line. So the same case is here. Since this planet is very far away and AB can be taken as an arc of a circle of radius d. So we know that angle is equal to arc upon radius. This you have learnt in the previous classes. So from this relation, arc is equal to angle into radius, or we can say that theta is the angle. So theta is equal to that is b is the arc. So arc is equal to d into theta, or radius d is equal to b upon theta. So from this relation we can find out the value of d, which is the distance of the planet from the earth, and that is equal to b upon theta. B is the distance between the observatory, which we can measure easily, and theta is the angle which we are measuring with the help of the observatories. So the distance of the planet can be find out easily by using this method. So having determined d, we can employ a similar method to determine the size or angular diameter of the planet. How? Now once we have determined the value of d, means the distance of the planet is known, then what we will see, this is the planet and this is looked looked from the observatory on the earth. Now this distance, we know we are looking the 2 points of the planet, that is A and B. By measuring the angle theta and the d, we can measure the length IAB, that is the diameter of the planet. So by using the Parallax method, first we will find out the distance of the planet, then by using d we can find out the radius of the planet. Now error analysis in experiments. Now measurement is an important aspect of physics. Whenever we want to know about the physical quantity, we take its measurement. Instruments used in measurements are called the measuring instruments. Now whenever we are using the instruments for measuring the quantities, there may be an error. So let us understand the meaning of the two words accuracy and precision. Accuracy of an instrument represents the closeness of the measured value of actual value. Precision means precision of the instrument represents the resolution of the instrument. Resolution depends upon the least count of the instrument, and accuracy means how near the measurement is to the true value, and precision means the resolution of the depends upon the resolution of the instruments, that is the least count. Now for an example, if a quantity is measured with the two instruments A and B, the reading of A is 2.54 centimeters say, and the reading of second instrument is 2.516, and the actual value is 2.53. Now just look at these. If we compare the actual value with the value measured by instrument A, we will see that it is more near the true value, while 2.516 is little bit less near to the actual value. So we will say that instrument A is more accurate, but the second reading is less accurate. But the instrument B has greater resolution as it can measure up to 3 decimal places. So when we are measuring the same reading using the two instruments, then we can tell that which one is more accurate and which one is more precise. Now errors. The measured value of a physical quantity is usually different from its true value. The result of any experimental measured value contains some uncertainty. So this uncertainty is called the error. So error means the uncertainty in the measurement of any physical quantity. How these measurements can be classified into different groups, into two categories, mainly the systematic error and the second is the random error. Now what is the meaning of the systematic error? These error occurs due to the instrument used, imperfection in experimental techniques, or carelessness of the person. maybe it means instrument may be wrong, your technique may be wrong or not the appropriate. The third one, technique is correct, instrument is correct, but if the person is doing carelessly, then in all the cases the error will be there in the measurement, and such error is known as a systematic error. These errors tends to move in one direction only, means either it will be positive or it will be the negative. Now, random error. The random error occurs irregularly and therefore random in magnitude and sign. These errors tend to move in both the directions. They may arise due to unpredictable fluctuations while performing the experiments. For example, there is a sudden fluctuations. Now, when you are measuring the voltage and there is a sudden fluctuations, when you are doing the Ohm's law experiment, then there are the sudden fluctuations and you are measuring the current and the value of voltage, so they may vary. So these errors can occur randomly. These errors can be minimized by taking a large number of observations of the same physical quantities. That is why when you perform an experiment, then you take the values 3, 4 or 5 times. So if you increase your number of observations, then the average of the observations will give you the result very near to the true value. Now, accidental error. Sometimes the measured value is too much small or too much large than the average value. This is called the accidental error. These values are dropped before calculating the average value. Instrumental error. These error depends upon the instrument used to measurement. Mainly following two types of error occurs due to the instrument, that is the zero error. It is a type of systematic error. It occurs due to the improper positioning of the zero mark of the instrument. For example, if you are measuring the length of any object using the meter scale, and if you not put the zero on the initial point of the object, then the reading may be different. If suppose you are putting, your scale is broken, and instead from the zero you are putting the initial point of the object on the 1 centimeter, then the reading would be different. You have to subtract 0 to 1 centimeter from the measured value. So such type of reading is called the zero error. The least count error. This error is associated with the resolution of the instrument. Least count has been discussed in detail in your previous lecture. The least count of the vernier calipers, least count of the screw gauge, etc. Now, absolute error, relative error, and the percentage error. Now, mean of observations. Now, suppose you are measuring the quantity n times, that is x1, x2, x3 and n times. Then the average of it. How you find average? You will add all the values and divide it by n. Then this will be, you can get out the mean. So mean can be represented in shorter form like this. X mean is equal to, this sign is known as the summation of x, consa x from xi, that is from I is equal to 1 to n. So this is the sum of all the values, and when you divide it by n, then this will give you the mean value. So mean value is 1 upon n summation I is equal to 1 to n xi. So arithmetic mean of these observations is taken as best possible value of the quantity under the given conditions of the measurement. Now, absolute error. The magnitude of the difference between the true value of the quantity and the individual measurement value of the is called the absolute error. So what does it mean? That is arithmetic mean that will be taken as the true value. So if you are taking 10 observations, you are finding the arithmetic mean, so that will be considered as the true value. If you subtract each value from the mean, so x mean minus x1, then this will give you the absolute error. So the difference between the mean value and the true value or the particular value of any value of any observation, then this gives us the absolute error. So absolute error may be positive or negative. And if you add all the absolute errors and divide it by n, then it will be give you the absolute mean error. So the average of the mod of error is called the average or the mean error. Why it is mod? Because the absolute error may be positive or negative, so you have to take the mod. Mod means you will drop out the negative sign, you will consider only the positive sign, add all the values, all the observation, or all the absolute values, error, sum it, divide it by n, you will get the absolute mean error. Now relative error. If you divide the absolute mean error with the mean value or the true value, this will give you the relative error. Percentage error, if you multiply it by the 100, then you will get the percentage error. Now these are usually used in the numericals: the absolute error, relative error, and the percentage error. Now whenever we are measuring any observation, means suppose if you want to find out the area of a table or area of any square, so means you are measuring the length and breadth. So this is the combination, means area will give the combination of the two measurements. So whenever you are measuring two or three physical quantities, or when we perform some experiment, different observations are used to get result using algebraic operations like addition, subtraction, multiplication, division, etc. Then we need to calculate the error in the combination of the various mathematical operations, means this is the combination of error. Now for an example, the error in sum or difference. Now suppose if you have any quantity x which is the sum or difference of the two quantities a and b, then what will be the error in the measurement of x? This we are going to find out. That means when you measure any object, any quantity a, it may have some error. When you measure b, it also may have some error. When you are adding these two quantities, then what type of error may occur in x? This we are going to find out. So now let del a is the absolute error in the measurement of a, del b is the absolute error in the measurement of b, and del x is the absolute error in the measurement of x. Then x plus, यहाँ माइनस भी होना चाहिए, x plus minus del x, s plus minus x is equal to a plus minus del a plus minus b plus del b. Now इस पूरे एक्सप्रेशन को we can reduce it, a plus minus b, del a and del b इस साइड ले गए एक ब्रैकेट में, plus minus del a plus minus del b. Now in place of a plus minus b we can use x, so we put x plus minus del a plus del b. Now if you compare the right and left hand side, we will get that del x is equal to plus minus del a plus minus del b. That means the maximum absolute error in x is equal to plus minus del a plus del b. That is the maximum absolute error in sum and difference of the two quantities is equal to the sum of the absolute error in the individual quantities. Means if you are adding or subtracting, whatever may be the absolute error in each quantities, that will be added, whether you are adding or subtracting. Subtraction means does not mean that the error will subtract and result will be 0. No, in both the cases they will be added. Now error in product. Similarly, if the quantity x is equal to a into b, then x plus minus del x is equal to a plus minus del a, b plus minus del b. Now here we are going to find out the value of del x. So if we follow these steps, what are these steps? You have taken x common here, similarly ab common here, x and ab will cancel out, then this expression will reduce to this one, then again 1 and 1 cancels out and the expression reduces to this one. Then since del AB and del B by B is small quantities, so in their product can be neglected, and the result we will get that del x upon x is equal to del A plus upon A plus minus del B upon B. So we can say that the fractional error or the relative error, fractional error in product of two or more quantities is equal to the sum of the fractional error in the individual quantities. So when you are multiplying it, the error will not multiply. In fact, the relative error will add in both the relative error of both the quantities of both the measurements. Similarly, the case will be in division. Division also, let x is equal to a upon b, then x plus minus del x is equal to a plus minus del a upon b plus del b. If you simplify it, we will get del x upon x is equal to plus minus del a upon a plus del b upon b. So the result is important, that is the maximum value of the fractional error or relative error in division of two quantities is equal to the sum of the fractional errors in the individual quantities. So again, when you are multiplying or when you are dividing, in both the cases, the relative error in the resultant will be the sum of the relative errors in the individual quantities. You can understand this when you use these in numericals. Now, error in quantity raised. Now suppose if the quantity x is equal to a raised to power n upon b raised to power m, means power along with the division. So then maximum value will be like this, del x upon x will be n times whatever is the power that will be multiplied it, n times del a upon a, the power b, just look at this sign, this is plus m del b upon b. So when they are, the two quantities are dividing, even in the result the errors will be added, and if the whatever be the powers, they will be multiplied. So these are the rules to find out the error in the combination of the measurements. Now let us solve the two numericals, you will understand it better. The temperature of the two bodies measured by a thermometer are T1 is equal to 20 degrees centigrade plus minus 0.5 degrees centigrade. What does it mean? The temperature can be 20 plus minus 0.5. Either it may be more than 0.5 in 20 or it may be 0.5 less than 20. Similarly, T2 is 50 plus minus 0.5 degrees centigrade. Calculate the temperature difference and the error therein. So now we have to find the temperature difference. T dash is equal to T2 minus T1. T1 is 50 plus minus 0.5 and T2 is 20 plus minus 0.5. So here we are finding the difference. So 50 minus 20 you will get 30 degree, but the errors will not cancel out each other. They will add up and we will get plus minus 1 degree centigrade. That is, the difference will be 30 degree plus 1 or minus 1. So this is the method to calculate the error in the resultant. Now let us say the next question. The resistance R is equal to V upon I. You know this formula. V is 100 plus minus 5V and I is 10 plus minus 0.2. Find the percentage error in R. So before the percentage error, we have to find the relative error. How you will find the relative error? Now what does it mean? 100 plus minus 5 means 5 is the absolute error. Now absolute error को percentage error, relative error में convert करने के लिए del A upon A. So here del A is 5 and A is 100. So this is the relative error. For the percentage error multiplied by 100, 100 cancels out and the result is 5%. So the error in the measurement of V is 5%. Similarly, for the I, del A is 0.2, A is 10 multiplied by 100. This will reduce to 2%. So percentage error in measurement of current is 2%. So 5 plus 2, that is the 7%. So then the question what is asked, find the percentage error in R. So percentage error in R will be the sum of the percentage error in V and sum of the percentage error in A in current, and that is 5 plus 2 is equal to 7%. Now let us solve one more example, one more numerical. Here Z is a raised to power 4, b raised to power 1 by 3 upon c d raised to power 3 by 2. Here we have to find the relative error. So relative error is del Z upon Z. Now power of A is 4, so 4 will be multiplied. 4 del A upon A plus 1 by 3 del B upon B. Now C is in denominator, but when we are finding the error, it will be added again. So plus del C upon C, then again plus 3 by 2 del D by D. So powers will be multiplied, and whether it is in denominator or in numerator, all the relative errors will be added. So in this manner we can find out the relative errors. These three numericals, if we say from the examination point of view, so such numericals are important. So thank you. That is all for the today's lecture.